Hey students, welcome to another lesson in physical geography. Today we're going to talk about portraying the Earth. How can we take this oblate spheroid that we call the Earth in the solar system with all the rotation and the wobbling and the revolutions around the sun that we learned about in previous lessons? How can we take this and represent it in a way that you and I can understand it? Many times it has to be in just two dimensions, even though we have a three-dimensional object that we're trying to understand, and that three-dimensional object does not have a smooth surface either, and it's got an atmosphere that interferes with all kinds of sensing and measuring and portraying it. So we're going to look at all the topics from chapter 2 in this set of lessons, and that's your reading assignment, chapter 2. It's got a variety of different things. It changes topics. It relates to portraying the Earth, but it changes topics in a nice way, I think, for our modern attention spans. You can read a couple sections and then you get to focus on something else in the next sections before we complete the chapter. So we're going to read all of it. And when you read it, you're going to learn about maps more than what we learned about in our latitude and longitude lessons in our most recent weekly folder or lesson folder. We're going to learn about how the different map projections, the distortions that can happen, the issues that we have with portraying the globe in two dimensions. I don't have any lessons prepared for you about the flat Earth theories that are out there, but it might be something fun for you to do a little research on, but don't look at the flat Earth theories in a way that is serious at all. Use it for a fun kind of activity to see whether they have any scientific background whatsoever in their analysis of how to portray the Earth from their point of view. We've got a lot of scientific background, and we've got a lot of imaging and remote sensing and global networks of technology that can give us our data about how to portray the globe and what we look like, the citizens of the Earth on the Earth look like in the solar system. We've got a whole lot of science in our court, and so you can teach yourself what the science is by looking to see what's missing in things like the flat Earth theories that are, they seem to be resurfacing quite a lot. I guess they never really went underground. You just are hearing about them more often these days. At least I do, since I have geography in my algorithm. It shows me that in X and in YouTube and then in the other social media platforms that I frequent. I get a lot of geography feedback because it's in my algorithm, and so occasionally there's something in there about flat Earth theories, and I don't remember seeing that too much. Years ago. Not that YouTube and Facebook and all these things have been around for just centuries or anything, but the algorithm has changed over the decade or so that I've been using this stuff. So it could be a fun thing for you to explore and even use an outside source, debunk an outside source, identify an outside source, and debunk an outside source using the information that we have in this chapter. Could be a good opportunity for you as a reflection journal for this particular chapter. Okay, so I've got a couple things listed on my small dry erase board back here of what we're going to cover in this particular set of lessons. So definitely maps. There's lots of different map projections. They have people's names associated with them, and they offer distortions. They offer different ways of taking a globe, the three-dimensional object, and putting it into a two-dimensional form that we can use for a variety of different purposes. So for instance, navigation was one of the first purposes. Navigation and showing territory, where autonomous territory was, or a political territory was, like the Roman Empire or something. And so these kinds of maps give us information about a particular region, the R of Mr. Help, a particular region on a globe, or they are created for a particular purpose. And so, for instance, the Mercator projection, which you'll learn about in the textbook and also in one of the next videos that I made for you, this is the most popular projection of maps in the world because it is so easy to use for navigation. And if you are like me, even though I love geography and I love to understand maps and directions, north, south, east, and west, and all of these different things, I use my GPS or global positioning system on my iPhone a whole lot. I'll ask Siri, where is the nearest whatever. I used Taco Bell as an example in one of my last videos. So where's the nearest Taco Bell, for instance, to where I am right now? And Siri doesn't say it's north northwest, and she doesn't give us latitude and longitude identifiers. She'll say, you know, turn right up here and veer left, and it's the second driveway on the left after you do that. So that's the kind of way that we have learned to navigate using GPS instead of the old road maps that you could get. Stop at the Flying J and get yourself a laminated atlas that you can look to see what the interstate and the state highways are as you travel from California to Maine in our 48 contiguous United States. Anyway, we don't do that anymore. We don't have to print out or write out the directions that we go because usually our GPS does that for us. Well, we're going to read about how that works, all the different satellite systems that are in orbit that send messages from one to the next so that you can find your way and you can track your little blue dot, you know, on the navigation system in order to see where you've come from and where you're going. But usually, you know, and here's another thing that you can do as a reflection journal for this particular unit. If you don't want to do the flat earth thing, I understand, believe me, you might not want to click on those things in your algorithm. I do sometimes just so that I can talk to you about them, and it kind of messes up my algorithm a little bit. I get some stuff that I don't really want, but I've only just used for academic purposes. But anyway, if you would rather, you know, pick a place where maybe you haven't been before and put it in your navigation system and see what the route is that Siri takes you on or Alexa takes you on in that navigation system. And then find online a map that you can look at and try to see whether, first actually try to guess, is this north, is it south, is it east or west from me? Because a lot of times students your age, I assume you're a couple decades, 3 probably younger than I am, a lot of times students, even in my generation, we weren't really taught to perceive north, south, east, and west from where we're standing right smack dab at that moment. A lot of times we you know, we know that we have a window to our left or a window to our right, but we don't know what direction we are looking at out that window. And so I challenge you to try to guess to see, you know, where this item is in location to you, and then find a map that portrays that area. And see whether you're right. Check yourself and see whether your GPS gave you any kind of indication about whether that place was north, south, east, or west of you. Make sure that if you use that as your activity for a reflection journal for this particular set of lessons, make sure if you look something up and you need to cite it, do that, because you need an outside source several times as you do that reflection journal. So go ahead and do that. If you don't look anything up, if you just happen to look at your GPS to see if you already know something is northeast of here and you look it up on your GPS to see whether it gives you that information, and it doesn't, that's not an outside source. That's just an activity that you can describe for me. Okay, so yes, so when we read maps, we have to know things like the locations, the cardinal directions, the north, south, east, or west, and there's a lot of other information on legends and on scales that you need to know you know, about to interpret that map correctly. And so a scale shows you how much distance is represented by how much distance on the smaller map. So maybe an inch is equivalent to 100 miles or something. And so there'll be a scale that's represented. Miles, of course, is what you'll see on maps that are produced in the United States. Your GPS is probably defaulted to miles of distance between one place and the next, wherever you're going. But in other parts of the world where they use the metric system, they're gonna have kilometers. They're gonna have how many kilometers between here and the next location. And so your mindset is very different also as you think about distance and time and how long it takes to travel. We are accustomed to how many miles per hour we can go or miles per gallon that we can go. And other places around the world that use the metric system don't think about distance in terms of miles per gallon or miles per hour. They would think about distance in terms of kilometers per hour or kilometers per liter of fuel and that kind of thing, or kilometers until the next charge that you have to make on your electric car and where the location for those charging stations is and that kind of thing. So this chapter gives us just a really good solid foundation to stand on to understand literally our place in the world and how to interpret things for directions, for understanding what a map was produced for, interpreting a map correctly. Remote sensing is another topic that we're going to talk about in this set of lessons. There are curated videos that I have for you to understand remote sensing and geographic information systems and those kinds of things. There are excellent resources online already, so I figure why reinvent the wheel when you have a lot more high tech and graphically stimulating videos than just me standing outside with my dry erase board. So with a bird that's too loud, probably hitting the decibels on your speaker right now. So there will be a few required curated videos that you need to take notes on for this unit, and then also another video or maybe two, I can't remember, that I've made for you specifically so that you can understand maps, map projections, the way to interpret maps, what ISO lines are. That's in one of the videos. It's definitely in your reading assignment, and that's what we're looking at in this set of lessons. And so please make sure that you take careful notes. Please make sure that, for instance, for this video, you do have these think of these as bullet point items on a list, and make sure that you explain what, go back, rewind, back me up, and look to see what did I say about maps. Give yourself a little explanation in your notes. What did I say about globes? Give yourself a little information in your notes. How do we read maps, like the legends and the ISO lines that I just mentioned, and the scale of the map is drawn on, remote sensing, etc. These different things. Make sure that you write down an explanation for the notes, maybe keep track of what day or week this is so that you can refer to this lecture when you need to in your unit assignment that comes up at the end of our first section, our first unit of lessons. So please text me with questions, and I will see you in the next video. Bye.